Hello, I'm Ian with Amer Networks, and I'm here to demonstrate the WAN LAN Optimizer series from Amer Networks. First off, for this demonstration, we're using the WAN LAN Optimizer 880F, which is our SFP version that allows for mini gigabit connectivity for fiber and copper. The important thing to note about the WAN LAN Optimizer product as a whole is that it does function as a transparent bridge and does have to be installed inline on your network. You'll notice in the interface status area that interfaces 0 and 1 do not have IP addresses because they function as a transparent bridge. Ethernet 2 is a dedicated management port which you assign an IP address to, which you can access this user interface or access the device through SSH. The first area of this product we're going to explore is the visibility section. We're going to go into the top talkers area, which is going to display the real-time information of who and where people are connecting to and how much bandwidth is being allocated to those sessions. The device also has the ability to export in NetFlow version 5 and version 9. NetFlow is a Cisco protocol, but has since been created and adapted into multiple different ways to display bandwidth data. In this section, you have the ability of choosing whether you're going to export in version 5 or 9, and the collector address. Now, we have a server already set up to collect this data. You can use any server that supports NetFlow version 5 or 9, Scrutinizer, SolarWinds, or Manage Engine. In this case, we're going to be using Manage Engine to display the data. This is a Manage Engine version 9 server that's running in the free edition mode. You'll notice that it is displaying the device name. It is also showing the top protocols that are being used on the network. It is also showing the bandwidth going in and out of the interface. Now, because we are using this as a transparent bridge, the data that's being displayed is actually mirrored. So you'll notice that it is opposite on Ethernet 1 as it is on Ethernet 0. Now, we can actually dive into each individual interface and look at this data in more detail. You'll see that we have an MRTG graph on the center of the display displaying the upload and download traffic. We also have a table below showing total up and total down, as well as max up and down traffic, and then we have the 95th percentile and then average. We can also zoom in on any section of this graph to get more detailed information. We can actually change the tab at the top here to display applications. So we can actually look at that time range that we've selected and see what protocols were being used. In this case, POP3 was the top used application, so we can actually zoom that protocol and look at where people were connected to, which IP addresses on the local LAN were using those protocols. We can even do a reverse lookup to determine where these users were connected. Now, we also have the ability of looking at the source and destination IP addresses, so we can actually look at the top bandwidth of users on the network. So we can see here that 192.168.150.144 was using the bulk of the traffic, likely doing a large email download. If I go back to the Traffic and Applications tab, I can change my selection to back to the last hour or to another date range or time range that I would like to specify. You'll notice here that we actually have unknown applications that amount to 1 megabyte of total traffic in the last hour. I actually have the ability of looking at those application ports to identify a possible peer-to-peer use or other miscellaneous applications. If I identify a port that is being used that I recognize, I can actually add a mapping myself for that and label it, and it'll be used to report in the future. Going back into the device itself, under the visibility side, we also have statistics that show, based on all three interfaces, the total TCP, UDP, ICMP, and ARP packets that are being transmitted up and down. We also show other sessions, drop packets. We also show DDoS attacks, as well as anything else that the device is blocking. Under the optimization section, we can actually look at the current policies. In this demo, we have removed all policies out of this device. Now, the device does come with a predefined default policy. You can specify whether that default policy is going to permit or deny traffic. You can also specify whether the default policy is going to export NetFlow and also collect top talkers information. We can actually go in and create address objects for our policy creation. So in this case, I'm going to add in the local LAN. I'm just going to label it LAN. And I'm going to put in the IP address range for that LAN. Now I can also put in a range or designate a subnet. So in this case, I'm going to use a 24-bit subnet to cover the 192.168.150 range. Now before I create an optimization policy, let's get a baseline on how much bandwidth we have to work with. I'm going to start a bandwidth test running from our local ISP. And while that's running, I'm going to go back and create a bandwidth policy. So I'm going to start by creating a new optimization policy. I'm going to go local LAN, select the address object that I created, and then move over to the traffic management tab. Now, when we create a traffic management tab, we can do this with application port, so we can specify a specific service that we want to limit, or we can select all services. We can also select what we want to do with this service. So in this case, we're going to do the all services going through this device. Now we have the ability of permitting, denying, or limiting. So in this case, we're going to create a limit. And now we have the option that's popped up that allows us to specify a little bit more granular on how we want to limit this data. We can choose all hosts combined, which basically amalgamates all of the IP addresses trying to access services on that range that we created with our address object. And we can set a static limit for all of those addresses, or in this case, we're going to set a limit per host. So I'm going to set a limit here of 1024 kilobits per second, which is 1 megabit. And I'm then going to go into my scheduling and logging. We have the ability of scheduling this policy to go online and offline at specific dates and times. We can also make this a recurring policy so it turns on and off on a daily basis. And we also have the ability of specifying what goes into the event logs and what doesn't. We can also specify for visibility whether this is going to export NetFlow data or also top talkers. Let's go back to our speed test to check this information before we actually enable that policy. So we're showing roughly 6.5 down and 6.5 up is available without any bandwidth management. So I'm going to actually apply this policy now and rerun the speed test. So we're going to wait for the speed test to complete. And this is going to show that we have an aggregate bandwidth up and down of 1 meg. There's our result. Now if we go back into the device, creating a local LAN limit policy is one of the most effective policies you can create. In most organizations, there's only a static amount of bandwidth that's available in the sense of, say, 10 or 100 megabits per second that are available to the organization. When dealing with organizations like schools or large universities outside of the K-12 space, or dealing with an organization of maybe 500 to 1,000 workstations, you can create a rule that allows each workstation to get a maximum amount of, say, 1 or 2 megabits per second, which is more than sufficient to do day-to-day operations accessing the WAN. Now, we also have the ability of creating additional optimization policies that allow you to do things like permit. So let's create another address object and let's dedicate bandwidth to a server. So let's say this server is residing at 192.168. Let's go with 125. I'm going to say a 32-bit subnet mask to just specify this one IP address. Now that that's added in, I can create a new optimization policy, specify that server, and create a traffic management policy that is designed to allow traffic to go to and from that server, and basically no limits. So I can actually move this policy above the local LAN policy, so now anytime that server needs to access data, whether it's coming in or going out, it's going to have guaranteed bandwidth over the 1 meg limit that I've set for the rest of the LAN. Now we can specify that to be more granular based on services, based on other application ports. We can also base it on a group of servers or a address group or service group. Now I can also set a static rule above that server that can actually limit everything on the network to a static limit. So I can say, again, local LAN total, specify the services or the address group as the LAN, go back in and select all applications and say a limit. And in this case, I'm going to say all of the devices on the network are limited to 5 megabits, which means I have some overhead of a half meg available for inbound communication, perhaps a VPN. And I'm going to move that rule to the top. So now the rule base that I've created is ultimately there's a 5 megabit limit to everyone and everything on the network. We have our servers permitted so they can access anything as long as it doesn't exceed the first rule. And then we have the local LAN rule, which offers a 1 megabit limit per device. Now we also have the ability of modifying schedules. I mentioned that earlier in this demonstration, where we can add scheduling objects so that these schedules enable and disable at certain times, whether it be on a date range or a recurring time. We can label it and it can be applied to any day of the week. The last area of the optimization and limits is the ability of creating rules that apply to deep packet inspection. So we can actually create DPI rules that apply to the entire network, and we can actually, instead of selecting a service, we can actually select an application. Applications are pre-populated in the device. They actually look into the packet header of everything that's going across the device and allow you to do a allow or block of specific traffic. In this case, we're going to block peer-to-peer, which will block BitTorrent and any other peer-to-peer traffic that meets and matches our definition that we've created. You do have the ability of creating and adding your own packet definition, so you can filter based on streaming media, voice over IP. We also allow you to create dedicated rules, so you can move this to the top of the policy chain to basically guarantee a bandwidth. And then last with the device, we have the ability of logging all this information into a syslog server or multiple syslog servers. Another inherent quality of this device is it has the ability of doing DDoS and DOS blocking with SYN flood blocking, as well as additional deep packet inspection signatures that are looking for other malicious information to come from the WAN or the LAN. That concludes our user interface demo.